It's nice to see you here tonight, and I would like to take you with me on a journey. This journey starts from a problem that many of us may be faced when we want to buy property or sell a property, starting from the problem all the way to the solution. So some of us might remember from Computer Science 101 that there's something called the problem space or the problem universe. There are many problems in the world that we simply can't solve. We have no way of solving. For example, if someone wants to go beyond the Milky Way, visit the next galaxy, sorry, we can't do that in our lifetime. The fastest thing we know is light, and light will take many years to get there. So that's not a problem we can solve at all. So some of the problems that we can solve can be computerized, some can't be. And we're more concerned about problems that we can solve using computers and are feasible to solve, actually. And just to give you an example, here is a screenshot a friend of mine sent me not long ago. His client was hit by a ransomware, and they asked him if you could fix it for us. So he tried this password cracker just to kind of figure out what password was used to encrypt their data. He said 8 hours, I think, and at the end, it failed. It didn't work. I told him, mate, if you can't crack a password in 8 hours, we can't say goodbye to cybersecurity. Hell will break out. So he could have fixed it if he had access to all servers on Microsoft Azure network, for example, or if he could let it run for not 8 hours, but maybe 100 years. Now there's a chance that it will be cracked. However, if he let it run for 100 years, it might have cracked the password, but clearly neither option is actually feasible. So we are more concerned about problems that we can solve by computers, and they are also feasible. And as you can see, the more we go, then we have really a smaller circle. So from the problem space to the solution space, what we can solve with computers, what is feasible, and then within that feasible space, should we use machine learning, AI, or should we not? So that's a question. If you ask every data scientist, probably they will say, hey, yes, let's do it with data science. Maybe that's not always the best option. Why is that? Let's think of the traffic light rule. This is really a classic example. So it's quite simple, right? You stop on red, you drive on green, but what if it is yellow? Well, it's based on the situation. It depends. Depends on your speed, your distance to the traffic light, the condition on the street, and so on and so forth. Maybe if you are in a rush or not as well. So when it is yellow, then it is judgmental. There's no one fixed rule that you can apply. And this is a situation where you can actually think of machine learning AI as a candidate. Now let's turn on to house prices. You want to buy, let's say you want to sell a house, you own a property. The first question you need to answer is how much it will worth. And you have a bunch of options. So you could speak to a local agent, estate agents. They have local expertise, they have the knowledge. And you probably speak to a bunch of them, and they tend to overvalue, by the way. They want to win your instructions. And you'll realize if you ask 3 estate agents, you'll get 3 different prices. So you're not quite happy. What is your next move? You could be more professional and talk to a certified valuer, for example, RICS valuer. And interestingly, because they do have their guidelines, they have their red box, valuation red box, and all. If you speak to 3 certified valuers to value one property, guess what? You will end up with 3 different prices. So it's still judgmental. Maybe you want to try your luck with all these automated valuation. Everybody knows about Zoopla house prices. You can go to Zoopla website, check the price, and if you've been there, you know what I mean. I call them automated misvaluation modeling because they tend to misvalue properties for various reasons. And
as you can see, there is no one rule to value properties, which means it is judgmental, just like your yellow signal. So, okay, let's crack it with AI and machine learning. The first thing you will realize, this is real world. Maybe if anyone here is a data scientist, you might be familiar with MNIST dataset. There is no MNIST dataset for properties, unfortunately. MNIST is, by the way, a dataset that is pre-made, pre-gathered, pre-cleaned. It's for data science students. So the real world, there's no MNIST. So you have to start with a blank sheet and determine what data sources you can actually use. Probably you don't know. You need to do a lot of research just to figure out, oh, what data is out there we can use. So in the UK, fortunately, we do have lots of data. So land registry, price paid, that's one of the main sources. EPC, that's your energy certificate. Every property has to have an energy kind of ranking. And you will find that in the EPC certificate. Census data about areas, I mean, the income level, security, environment, and so on. OpenStreetMap, that will tell you if there are shops, restaurants, train stations, etc., etc. So there's lots of data that you can use. The challenge is, the more data, it's become more challenging to actually tell which one works for you and which one doesn't, which one helps your model provide a better valuation and which one doesn't. So this is going to be an iterative process where you try something and then you change again. And there is no alternative, unfortunately. When you work with large data sets, real data sets, then you will always find outliers. And outliers are observations, we call them, which are very different. They don't go with the norm. For example, a house that's way too expensive or way too cheap, for example, for whatever reasons. This is an outlier, and typically you don't want your model to learn from outliers. You want your model to learn from the right normal data. So what do you do with outliers? You need to detect them. And one of the algorithms you could use, for example, is clustering. So you create a cluster, and you'll find big clusters, which means, oh, lots of data there. So this seems to be good. And some clusters will have a fewer data points. These are likely to be outliers. You could exclude them. Well, this is just one of many ways to deal with outliers. Ideally, you want to detect them, and typically, I would exclude them from the training. You will also have lots of missing values, zeros, NAs, NaN, empty string, call them whatever. H2O has a nice feature. It's called mean imputation. So if you are training a model which has some numerical columns and they have empty values, H2O will automatically find the mean, the average of the value of the column, and substitute. Now, this might work in some cases, but in most cases, it doesn't. For properties, for example, the average, anyone knows what is the average house price this month? It's about, in the UK, well, in England and Wales, it's about £270,000. In London, it is £620,000. So you definitely don't want to substitute the wrong value. So you could, for example, create your own imputation value. So what is the average price in London? You use that value to substitute any missing property in London, for example, when training your model. There could be other ways. You could just exclude them, in which case you will lose most of your data. To me, the worst offender is actually incorrect values, because sometimes they are very hard to detect. So, for example, that house, it's recorded as 3-bedroom flat. It might have 4, not 3. Now, this is very hard to detect. There is no way to actually tell. I don't know any way to deal with this. If they are way different, they will appear to be outlier. They will be dealt with. Otherwise, unfortunately, you still have to deal with them. They are still in the data. There are other things you need to worry about. We talk about house prices. So, for example, I use data from 4 or 5 years ago. And you know about inflation. So if a house was sold 4 years ago for £200,000, today it's not going to worth 200,000. It will worth more due to inflation. and you have newer data sets. So you need to bring those historical records to date. So you need to apply inflation to these values just to make sure your data set is consistent, is clean, is good. Ideally, you want to turn this mess into something very neat, very clear, very clean that you can train your models with. And when you are ready, then you can use H2O, for example. So with H2O, you have options. So for starters, you don't know which algorithm to use, right? Should you use random forest? Should you use deep learning? Should you use HD-boost? There are many, many different algorithms. A good way to start, I would say, is to use what they call AutoML. So basically, you provide the data, you tell H2O predict the house price, and you leave it run overnight or over the weekend. It will try randomly many, many different models, and at the end of the day, it will show you what models score the best accuracy. In this case, the best valuation accuracy. And if you see a pattern, for example, the top 3 models are all neural network, then you can have an educated guess that using ANN, artificial neural network, is your best bet. So your next move would be to try something called grid search. What grid search does is that you say, okay, I'm interested in ANN, but I'm not sure how many layers should I have, how many neurons should I have, what is the activation function should I use? So with grid search, you can say, okay, train a bunch of artificial neural network models and try all of these, they're called hyperparameters. And then you can see at the end of the day which hyperparameters gave you the best results. And normally you want to fine tune this process. So you might change something. It's always iterative. It can be time consuming. One option, if you don't have a lot of time, you don't want the headache, and you have some cash to spare, you could go with the driverless AI. So that's H2O kind of flagship product, I believe. I'm not sponsored by the H2O, by the way. What it does is that it does some sort of AutoML grid search, but I also believe, Joe can confirm this, it will do some kind of data manipulation for you. It will create statistical columns, for example, automatically to help the algorithms become more robust and more accurate. And that's a product you can try. Either way, you will end up with something like this. This is actually a screenshot from a trained model, and the name suggests E12 That's actually the London region. So this model is trained to value properties in London. And what you see is just a boring flat file, doesn't even have an extension or an icon, but that's your trained model, that's a knowledge, that's all your hard work in this file. So if you are a researcher, that's good. All you have to do is just go and publish your findings. But if you are in business, why the heck did you train this model? You need to do something about it, right? And to do that, you need an entire infrastructure. Well, it might be big or small depending on the needs. In this case, as you can see, the AI part is actually only a small part in the whole system. So this is an example. This is actually a kind of simplified chart of AccuVal. That's our property valuation platform. What it does is this is the API part. So if there is a client that has a computer system, they want to send requests to say, hey, this is a property in this postcode. It has these features, how much it's worth. So they would send a request through the API. You need to have an API gateway to receive that request. Typically, you want to have some kind of authorization and authentication. You provide them with an API key. API key essentially is like the password. And that will also tell who used that system. And then you will need to have a system where you can pre-process the data. The client will only send maybe the postcode and some basic information. When you do a prediction, you need to have the data in the same format, in the same structure. And the model is trained with hundreds of data points or attributes. So that will happen automatically in the background. by the system. Obviously, for that, you'll need a responsive database. I believe this will be the topic of the next presentation. And then when everything is good, then you send the request to the AI serving platform. You remember that file you saw earlier? After some conversion, and it will do a valuation, will send it back to the client. Now, this is an API thing, so it might be a little bit boring, but I have something more exciting. Hopefully, it's going to work without a hitch. And we can do this online now. We can value a property interactively. So this is, by the way, this is a beta version of AccuVal, the valuation platform. All we need to do is just define the property. So let's say we want to value a flat. That's fine. It's leasehold, obviously. Let's say it is actually a new one. And let's say 2-bedroom, 1 living room, that's fine. Maybe slightly smaller, 650 square feet. And energy rating is B, that's fine. And it is very new, 2012. Let's say it's in a very good condition, maybe above average, and you need to provide only the postcode. Let's say, for example, and all you do is click on the calculator button, and it's going to take a few moments, and bam. We do have a valuation in a green badge, which means it's very confident. So what happens here is the data that are provided was merged with additional data in the background. It was sent to an AI serving platform, also on the back end, provided a house price value with a confidence, which is green coded in this case. And there is a bunch of data. And something I find very interesting about H2O is it took a few seconds not to do the valuation, but to generate all of these charts. I call them valuation evidence. And this is actually called the variable importance. So this is extracted from the model. I never hard-coded any of these charts. This tells you what is the price and how for example, the floor area affect the price. Obviously, bigger flats, bigger apartments, higher valuation. And there are other things. So you'll see, for example, the condition plays a very important part in the valuation. These are actually called partial dependence plots. So what happens is data about the area is sent to H2O, and I say, hey, tell me, in that area, in this case, for example, Sudbury, how house prices are affected? What variables affect house prices and how? And that tells you how it's happened here based on the attribute, whether it is area, the number of rooms, the type of property, and so on and so forth. What I think is very interesting about using machine learning, AI, instead of the classical approach. Anyone here works for Zoopla, HomeTrack? Okay, good. So what they use is they have a traditional approach where they hard-code evaluation somehow. They have kind of hard-coded algorithms or decision tree to value existing properties. If you want to say, okay, what if the condition of the property was actually even better, and you drag that to excellent, and you do a revaluation, and what's going to happen is based on the learning, it's going to generate a new valuation. So if you find a property that is not in a very good condition, and you say, what if I flip it, renovate it, how much I can get? So you can actually experiment with H2O. Hopefully you will find interesting values before investing your money in refurbishment. And I think that's all thanks to the machine learning approach. And I use H2O, obviously, and I found it to be very interesting because most of the data I use is actually a kind of CSV comes from files. So these are not images, not pixels. And this kind of data, lots of categorical attributes as well, such as the type, such as the place, the area, the name of the city, or the code of the city, etc. So this kind of data is, people use TensorFlow normally for images, but I think H2O is very, very efficient to use with this kind of data that you will find in most organizations. I hope you find this entertaining, and you can play with AccuVal. It's open, it's free. As you can see, it's accuval.co.uk. I don't gather any personal information, so everybody can use it without me knowing. So I hope you like it, and I'm happy to answer your questions.
Hi, great talk. I have a question about accuracy. How do you explain to a client that it is really reliable? How do you explain accuracy?
Okay, that's a good question. In fact, what it means for a valuation to be accurate, and when you ask an estate agent, they provide you with an opinion, right? So AccuVal is actually trained with the sold prices. So the way I measure the accuracy, and some of the gentlemen asked me before the event, how do you measure the accuracy? How do you know it's accurate? It's actually tested against land registry data. So the models are trained with a part of the data set, but you keep one part that you don't use for training. You use that for scoring, and then your model will value properties it never seen before, so it cannot cheat, if you will. And then I see how far it was from the actual valuation. Now, I have actually I have published a case study, which is actually on the website. If you are interested, later on you can read it. It's a little bit technical, a little bit detailed of the methodology. So I don't only publish results, but I also publish how I generated, how I reached this conclusion. So you might be interested to see this later on. So in a nutshell, that's how it is. I tested against recently sold property data.
I mean, I find it such an interesting area. I actually looked at it years ago and didn't really get as far as you did. So, well done. But the question that tripped us up back then, this was before machine learning came along, was, well, firstly, people weren't interested in the price right then. They were interested in the price when they sold it, which could be 3 to 6 months down the line. And if some external thing, for example, 2008 or whatever, happens, the whole market tanks, your prediction is all of a sudden going to be way off, simply because nothing like that exists in your data. Or maybe that one event doesn't exist. So basically my rambling question, but the question is, how do you deal with those kind of exogenous events that exist outside the data set?
Very simply, I don't. Because that's something you can't predict. You don't know what's going to happen tomorrow. Well, what you could do is, based on the past trends, how likely the price will be next year, the year later, the year later. But that's assuming everything remains the same. And that doesn't happen often, right? Things do change. Remember, with AI, machine learning, and pretty much with everything else, garbage in is garbage out. So if your data source is not accurate, or it has inconsistencies, your output will be off. So I sort of refrain from trying to predict future values. I could only kind of predict the next 3 months, for example, or 6 months, assuming everything remains the same. And if you see house prices, the trend is upward, that's true. But it's not a straight line. You will always see small ups and downs. And this is something no one can predict at all. You can predict the straight line, hoping everything will remain the same. But that is very subjective, right? This is something I can never prove. So I thought, well, that's not something I would probably want to do. I want to do something I can do, which is to value properties now. What is the likely price right now? And then you personally work out how likely things will change. I remember people ask about, well, a new line is about to open, Elizabeth Line. So when the line was announced, suddenly all the properties around that line increase in value. See, nothing has changed actually. It's just a new information people did not have. And how much that would increase the value, nobody could predict. It could add 10%, it could add 5%. It's just, this is not something you can reliably predict with machine learning or with anything. So to me, I think I'll focus on what I can do best, and I'll stick to that.
Great talk. My question is around the, was there anything that surprised you in terms of the output? Once you trained the data set and it gave you the visual basis, was there anything that the platform was able to produce that you were kind of surprised by or intrigued by?
That's a good question. And in fact, how can I frame this? The first thing is I was surprised that it actually worked, because when I started this journey, I wasn't sure if this can be done at all. And I know many people tried, and when I mentioned Zoopla and HomeTrack and all these companies, I trust they tried at some point, and maybe the data was not there or the mindset was not there. Nobody wanted to take a risk, right? So they stick to what this hard-coded algorithms, and by that I mean if this and that, if that and this. So they have their own expert knowledge embedded in their models. Myself, I'm not a valuer. I never sold a property. I never bought a property. And it's just about data, really. So that was the first surprise. I would say the second surprise is when I actually managed to find the accuracy data from Zoopla HomeTrack, which they didn't do before. And I put that in the case study. And guess what? I'll not say AccuVal, but I'll say the ML AI approach is actually way better than the best in the market. And this is just the start. If you compare this to something that has been perfected over 15 years or so, with something that is self-funded, is simple, one-man show, I think it just proves that for this kind of situations, yeah, machine learning and AI is the way to go. You have to do it correctly, though. In the US, for example, there is a company called Zillow. And last year, they closed down a whole section after making, I think they say $500 billion in losses or so. Zillow usually actually uses a system similar to Zoopla. So they have their own what they call AVM, and they added some AI to it to recognize objects. If they see this kind of lighting, maybe they add 5% to the value or so on. When they actually started to use their own algorithms, they fail. They fail quite big, and they just shut down the whole department in one day. So I think there will be more surprises down the line. This is a new technology. Well, it's not a new technology, but I think it's a new way of valuing properties. So who knows? I'm ready for surprises. I like surprises, so I have no problem with that.
Sorry, me again. I don't mean to be difficult. But just to come back on that Zillow example, and correct me if I'm wrong, my understanding is that the problem with the Zillow model is, well, the problem with the whole business model was it took them 3 to 6 months to flip a property. And in that time, in some US cities, the market had turned. So I can completely believe that your model is better than theirs, but if the market turns against you, and it's taking you time to flip a property, I used to work in a hedge fund, so we kind of think about this. So if the markets turn against you in that time, that's how you build up your big losses. So I suppose that's the thrust to like the prediction. Because in practice, you can't do things at the moment. It takes time to flip the property effect.
They should have considered this in their model. Add a cushion, for example. Yes, please. Yeah.
How well does your model deal with scarcity? So let's say we're in outer regions of London, in neighborhoods where there's maybe one house sold every 3 months, but prices are constantly increasing. How well does your model predict the prices at the current state?
Well, I do update the data every month because land registry, that's the main source of data, releases data every month. So as soon as there is a new data set, I incorporate it. I might retrain the models to kind of reflect on the new data. So it's always, but that's actually a good point because people say, it means you are always behind. You are always, and land registry does not update all properties every month. So there is always a backlog. And I think my point is, if you start to use asking prices, the more current prices, and I know some platforms actually scrape data from Rightmove and Zoopla to get the asking prices. But you will see asking prices usually are exaggerated. And the final price is almost in every case is less than that. So I would rather be a month behind rather than try to be very current, but I will use data that is incorrect. And we know it's going to decrease over time. So that's something we have to deal with there.
But can you see actually the difference in accuracy when you go outside of London or other big cities?
This model is not only for London. The only example I showed you, that train model, because I train a model per region, and that's part of your kind of machine learning process. Should you train one big, large model for the whole country, or should you become more specialized and train a number of models for every region, or for every district, or for every city? There's no clear answer in the beginning, so you only will find out when you do lots of experimentation. So I do have currently 10 different models, one per region. I don't have Scotland and Northern Ireland currently. I plan to include them in the future. But accuracy-wise, usually it's kind of more accurate in London than in some regions. The North, for example, because the property prices are lower. So if you are off by £10,000, that's a big percentage difference. In London, if you are off by £20,000, sometimes that's negligible. So it's not just a percentage, but also the actual value.
Firstly, amazing talk, very easy to understand, really enjoyed it. My question is, like right now we're talking about more data, so there's like probably more rows, but suppose you have more features, more columns, could your model maybe, like since you're retraining it, I'm guessing you could add more features as well, but that would mean you would also have to include that in the explainability of your model, the graphs that you've shown on the dashboard, where you're trying to explain why, what costs why. So my question is, how far can your model take this? For example, can it include, suppose your data set doesn't have basements as a feature. So if you add basement as a feature, then maybe the prices change in one sense. Or for example, even more external data, like for example, new railway lines like the Elizabeth line. If you could add more information in terms of features, you think your model could scale like that as well? Like is there like basically capability for that?
Yes, you are absolutely right. I mean, the more information you have, you can incorporate, the valuation will change. And remember, if you think of stock prices, share prices, sometimes companies' share just spike in one day just because a new piece of information entered the market, right? So it's just the same way. The point is, when you use machine learning, then initially you don't know how far you can go. And I always say, with machine learning, really the sky is the limit. The more data, the more relevant, clear, clean, good data you can add to your model, the likelihood of your accuracy will increase. Remember, your accuracy will never be 100%, especially in this market where things do change quite a bit. So the more data you can have, obviously, the more features, of course, not just rows, but like you say, the more attributes or you can add to the model. It might increase the evaluation accuracy, it might decrease it. Remember, so it all depends. And a lot of the time when you have when you add columns that kind of add the same information to other columns, I just exclude that. So sometimes you don't want to confuse your model with lots of data that don't always contribute to the goal, to the valuation. Of course, you don't know initially, so it's all experimental. I keep saying this, I know, but that's the fact. That's how we live as data scientists. We have to experiment all the time, explore new data sources, and so on.
Sorry, can I get a follow-up?
Okay.
Yeah, so as in I wanted to understand, so suppose there's a feature that wasn't relevant before, so we excluded it. But now a feature is more relevant and therefore we must include it. So is it a person who's doing this? Like there's a developer who's running these models and checking each feature again and again, or is it automated in one sense? That's what I wanted to sort of understand. Like,
Yeah, I think the first question is to determine what new data you can add. That's only a human can answer that question. And then how it can affect the training. In my current approach, I do it myself. If somebody uses driverless AI, I think all you have to do is just show it to the platform, and H2O will deal with it, and it will tell you if you get a better result or not. Right, Joe?
that's correct.
So I'm really interested to kind of understand where you would like this to go. What's the big picture? Where, you know, world domination, how does it look for you?
This is actually the first step to me, because my aim is actually to build a kind of property listing marketplace. It's different from Zoopla and Rightmove. So by a marketplace, if you want to sell yourself, you can't sell your property. If you need a photographer, a videographer, a conveyancer, you can't look them up yourself. So you may not need to go with an agent. As a buyer, you'll have more powerful search tool to find the property you want, not just by specifying a location or a postcode. Why did I do this? Because the first question, if you are a seller, the first question you need to answer is how much? This is where you normally go to estate agents, right? So I thought, if I don't solve that problem, nobody's going to use my platform. So I have to solve it. And when you actually solve a problem, sometimes you realize, hey, this has a market. There is a whole bunch of lenders, for example. They need to have a quick valuation. They use Zoopla, by the way, most of the time, which is maybe good enough, but this could be better. Because it's new, it can create new possibilities. Like I said, if you want to flip a property, which is not in a very good condition, you can find out how much it's worth now based on that poor condition. What is the likely condition after renovation? You can only change a slider, and it will give you the valuation. And this is not hard-coded mathematics. It's all based on machine learning. I never hard-code anything related to valuation in the model. You can play with it and you will find out yourself. All right, I think my time is up. So thank you very much for listening, everyone.